Welcome back, Physics 30. Today's lesson involves what I like to call ray diagram. It is a skill that you may not learn before. If I teach junior high, I teach just basic of ray diagram. But when it comes to high school Physics 30, this is the part where you start to learn way more in depth about reflection and refraction when you face two different material. One is, as you may know, reflection. You cannot do reflection without a mirror, but we are going to talk about specifically curved mirror, and refraction, which we talk about lens. When it comes to lens, some people use the word converging and diverging, but I like to describe the shape of it first. Concave and convex. Now, depends on what you're dealing with. It may have a real image, or it may have a virtual image, and at the same time, it may have a same size, smaller size, larger size, those kind of situation, or even the image is reverse versus image that is upright, those kind of thing. Why this is important is because before we getting into the wave part of the particle, wave part of a photon, we need to understand that how these material works, because we're using prism in real life. For technology, we use diffraction grating, which also use reflection, and of course prism is for refraction. You need to understand those material, which we're going to use it for atomic physics. So it is good idea to understand the basic part of it. So this section, lesson number 6, curved mirrors and lens and ray diagram, I'm going to break it into two parts. One part, which is the video that I'm recording right now, specifically talk about the theory part. How can we predict the reflected or refracted images by facing mirrors or lenses? Number 2, we're going to use formula. Of course, formula way is what you probably do a lot when you face any type of diploma questions, because that's one of the easiest way to use. It's a simple algebra. However, I like to focus on number 1. Nowadays in diploma, you will understand that it's not necessarily about the property of a reflected or refracted new image. It's more about what kind of material you're going to use, and if you use those, what kind of image that you're going to have. And like I said, upright, inverted, smaller, larger, or it can be real, virtual. So to understand that, theory play a huge role. I prepare several material today. One of the material that I prepare is ruler. You should have rulers ready for sure. And I personally prepare this graph paper. If you don't have any graph paper, even though it is recommended because each of the grid is 1 centimeter, so we can give it be a little bit more specific. It doesn't have to be graph paper. It can be any type of line paper too, as long as you can draw some of the image, mirrors, those kind of thing. So without further ado, let's go with some kind of or types of mirror and lenses first of all. Let's go with the word concave. Now think about this last section of it. Cave. This is how I used to memorize when I was in a high school, which was a long time ago, but I'm pretty sure this will benefit you quite a bit too. Concave means things are going inside. So it looked like that. Imagine you're making cave, then you should be standing over here, probably using your trowel and others, and or pickaxe, depends on what kind of thing you're using it. Think about like a mining situation. You're going into the ground, right? By digging in what's in front of you. Concave look like this surface over here. So as you may notice, it's going inward. It's bended inward. Now, convex on the other hand is opposite. I call it fat type because it is going or bent outward. As you may notice, the line is basically going off it. So think about like a big belly situation. I'm rather going to use these perspectives rather than converging mirror, concave mirror, converging mirror and diverging mirror. I'm gonna rather use the word concave shape mirror, convex shape mirror. Same thing happened for convex lens and concave lens. Now, you will see the word converging and diverging a lot. Converging, kind of consider that one as concentrated. So things are going into together. Diverging, you can consider opposite of concentrated. It, like the word, it says diverge, separate. It does not basically concentrate it to every single situation. Now, technically, in ray diagram, there are 3 components, which you can see 2 components over here. And even though it's 3, I'm going to go to 2 type of radiation. One of them that must go through an object and then go through the focal point. Another radiation that goes through the focal point and then reflected or refracted off from. One thing that I want you to understand is, of course, I'm going to tell you what the focal point and concave, the value that you see at F and C, for example, but let's hold that thought a little bit. Now, one thing that I want to point out is this. Any type of converging situation, which in this case, concave mirror, convex lens, can you see that solid line go through this F, which is known as a focal point? Think about that as a focusing point. Same thing that you see, except when it comes to lenses, they do not reflect, they do refract. Refraction is occurring, and when it comes to that, reflection is occurring. Those two. But you may notice solid line that go through focal point. That's one thing that you may want to have it in your mind. When it comes to diverging situation, focus on this dotted line. It does go through focal point, but dotted line is a one that you need to have it in your mind. Same thing for the lenses. It's go away, but dotted line goes towards a focal point. So that's something that you may want to have it in your mind. If the mirror is really round and becomes sphere, the parallel incident ray. First of all, what is parallel incident ray? Think about it in this way. Radiation is always straight. So you're looking something straight towards an object and through the mirror, something like that. Every radiation is parallel to this point of axis over here. They will not converge on the same focus. The further the radiation are away from the principal axis, which is this PA over here, the further they go away from the principal focus. So that means if I go move away, that's the point where everything is blurry because you cannot focus in the middle point over here. And that happened to our eyes too. And if you don't remember a lot, think about the funky type of mirror. In fact, if you take out your spoon, wash it really carefully, silver spoon works best. You can look at yourself from that concave side of the spoon and convex side of the spoon. If you look at convex side of the spoon, you will actually look like a little bit fatter in the middle side, like a little bit of a Snapchat filter, you know, the one that make your nose big, but every end of the face go a little smaller, like egg face. Or when it comes to concave mirror situation, you will see yourself a little bit inverted way. Your head is in fact located at the bottom, which is really hard to show in a video camera. So I want you to give it a shot. Just bring your spoon and then try to look at yourself as if each side of the spoon is a mirror. You will understand what I'm trying to say in here. Now, explaining everything in a given diagram, it's really tough in this lesson. So I'm gonna do quite a lot of example. But before we do, I'm going to explain to you what steps should I take to predict the image's size, orientation, and whether it's real or virtual, so type of the image. So here's the thing. Once we have an image and diploma exam 2, the middle part, the dotted line over here, that's exact center of the size of the mirror or lens, is known as principal axis. Every radiation, the first radiation that you should draw is always have to be parallel to the PA reflection. So what does that mean? Actually, I'm going to explain to you afterward. And then it's going to go reflects or refracts. Depends on what type of material you're talking with. Of course, mirror reflects, lens refract. And it has to go through F. So here's the thing. Imagine if I have an object that is about this size, then you have to go through parallel line to the PA over here, principal axis, and then if it's mirror, reflect and go through this F, something like that. If it is a mirror, a lens, then same thing, you have to go through that and then bend your angle, go towards F. This is a converging situation, if you will. If it's diverge situation, here's what happened. I have an object that high. Think about like candle, apple, whatever. You're gonna go towards it, parallel to the PA again. And now after that, because the surface is going around, it's gonna reflect off and going back. However, you're gonna have a dotted line in that case, reach to the focal point. If I have a dotted line, that means it's virtual actually. So I'm gonna do a little spoiler alert in here. If it's solid, it's a real image. If it's dotted line, it's a virtual image. If I look at diverging lens, same thing. I go straight through the object and then you separate it off. But from here, you're gonna connect using your dotted line, which is another reason why you will see virtual image in the mirror situation. Now, there is a second radiation. I kind of call this one radiation number 1. That's actually 3. I'm gonna get to you why I put 3 as a second one, and then second one as a last. The second part is completely opposite as the first one. You have to draw a radiation go through focal point first. Then you decide reflect or refract. So again, this is mirror situation and this is lens situation. And you have to go through the top of an object. So for example, like I said, if this is a case, you need to go through the focal point and reflect it off, and then that should be the one that I need to pass. If it's the one that is, in this case, going downward image, you need to go through focal point, then you're basically become parallel to the principal axis after that. Same thing for my reflection of the convex mirror, and same thing for concave lens. It is tricky, however we're gonna go through that one by one. Third one, which I don't really use a lot, this is the one where center of the curvature is what we call. Center of the curvature is F is focal point, focusing point. If this is, let's say, 5 centimeter, it's always double of that, 10 centimeter in this case. So if this X, that's 2X. Curvature, center of the curvature is basically the double distance of focal point. If your radiation directly go and back and forth, if it's reflected back, or if it's lens, definitely center of the lens, and then whatever the intersection point that we get from first radiation and second radiation, that's where the image will occur. The third one is double checking step. So I do not necessarily go through this radiation number 3. Right now, I can understand that you guys are confused if you've never done the ray diagram before. Hold your thought a little bit. I'm gonna go to that with examples, and then that will make you understand better. Now, before we go to any examples, the first step is drawing those 2 or 3 radiation to predict where my image will be located. And once you identify, you need to find out exactly which point the location is. An image always located where any type of reflected or refracted rays are intersecting together. So if I draw my first radiation and second radiation and there's an intersection point, that's where the image should be occur. And number 3 is describing the image. There are 3 that you have to answer. Is it larger side? Is it smaller side? Is it same side? Rarely this happen. Generally it's at the F, but you don't deal with that question a lot. Attitude, which is the orientation. Is it inverted or is it upright? Or type of it. Is it real or is it virtual? Like I mentioned, real intersection point is where, for example, I have solid radiation that intersect, that's real. Virtual is dotted line intersect, that's a virtual situation. Right now I went through a lot of information over here. Let's do some example. Actually, I'm gonna go to this summary table later. This is the one where you will actually benefit quite a lot as you go through this journey. So I'm gonna have that emphasized over here. Actually, homework question, I don't want to deal with the homework question a lot, but let's make some example. Alright, so prepare a blank pieces of paper or any type of line paper, it doesn't matter. Somewhere in the middle, let's have a straight line, and I'm gonna put that as PA, principal axis. Now, I'm gonna try to put it at the center. I want you to draw somewhere relatively in the middle, doesn't have to be exact in the middle, a little dotted line over here, and we're gonna draw several type of the lens and mirror. Let's do mirror first. Let's say this is concave mirror, the one that bended inward, because these guys will reflect towards on the left side. And let's say my focal length is 1, 2, 3, 4 centimeter. That's my F. Then my curvature, center of the curvature, or if you want to put it as C, that's the one where you need to do double the distance of F. So that means if it's 4, another 1, 2, 3, 4, that's where the center of curvature C is. And let's say I have an object that is between center of the curvature and F. This can be any object. I'm using a little bit of a arrowhead over here. If you want to draw a person, you can draw a person like that too. It really doesn't matter. This can be tree too. But in any case, I like to use an arrow. Now, first diagram. I want you to basically have straight line all the way to the mirror, and then after that I want you to reflect, in this case because it's a mirror and it's a solid line that go through F. have a good enough of distance, ladies and gentlemen, because this is how radiation number 1 should be, going straight through the tip of the object and then reflect it off, something like that. That's my radiation number 1. Radiation number 2 is opposite. In terms of step of the first one, you remember the second one, after the reflection, I went through the F, but the first step is I have to go through the F, but make sure that you're passing the tip or maximum height of an object, and then you're gonna reflect it off. Can you see there is an intersection point between 1 and 2, which is located right passing the C point over here? This is where my reflected image will be located at, ladies and gentlemen. So, this is basically how you draw everything. If you want to go through the third example, which is my, what was it? The going through the center of the curvature of the center, you can go through like this. And you may notice that, of course, my drawing sucks in here, but if you do it, you may notice that it's intersect exactly at this point over here. But long story short, that step is not necessary, just double checking parts. And now we are looking at the property of a diagram. Number 1, location, pass C. It's actually going beyond that. Now it's a property 1, 2, and 3. Size, first of all. Is that small or is it larger? Well, if I look at the height, 1, 2 centimeter object, and this is, or 2 meter, it depends on perspective. But when it comes to reflected image, it goes 1, 2, 3. It is actually larger image. Is this now attitude, upright, or inverted? This is inverted image, because the thing is, object is upright, but image is down. So you see things completely reverse situation, so inverted. Now third, type of an image, which means, is it solid line or is it dotted line that overlap? Right now I see that it's a solid line that is intersecting, so it is a real image. So these are my conclusion. The reason we're doing ray diagram is because so that we can identify these properties. So my reflected image located passing C, and then it is larger image, inverted image, and real image. That's what I want to point that out. Let's do similar example, except it's gonna be just different type of a mirror. Again, have a principal axis. I'm trying to draw with good enough of orientation. Principal axis over here, and I'm going to draw somewhere over here, maybe. Try to be delicate. And this time, instead of concave mirror, let's do convex mirror. So it is some kind of fat type. And let's say image is located over here. Image is located basically, we need to decide, why don't we put right after the F? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 4. 1, 2, 3, 4. C. Something like that. So I draw. There you go. That's F. And focal point can be located on either side. So let's deal with this question. First thing first. Radiation number 1. Parallel first. Have to pass the maximum height. Then after that, you may notice this is a diverging situation. Diverging means, think of your normal logical deduction or reasoning in here. It's bended, so it's going to go off this way. It's not going to go off that way unless it's cave shape, right? So it's going to go off. But you cannot just randomly put where it's go off. You have to put your ruler alongside with the F, so it's going this direction. However, I start to form a virtual line. Why virtual line? Is because the real image is impossible in this situation, because it's gonna reflect it off. That means my eye have a two choice. Am I going to see a real image? That's impossible already. My last choice. Am I seeing something inside of the mirror? Yes, it is. And that is basically my virtual image. So that's why I want you to put that. Now, other part. You may notice that when it comes to this shape, you cannot technically go towards in here. Actually, let's make everything a little bit more fun, actually. Why don't we make it exactly on F? That's actually a better diploma situation. So now what you need to do is, actually on F is impossible. Sorry. Let's go back. Same thing. F over here. Now, what do I need to do? Radiation, if I go this way, I cannot reach to this mirror over here. So what I need to do is, it has to go towards F. So as you may notice, I'm putting a straight line over here. But after that, I cannot go through here. I need to reflect it off parallel to PA. That's my second rule of it. So it's going to go back the way it's come from. But my virtual image, if I extend the line, I will have an intersection point over here. And that is my image, ladies and gentlemen. So let's answer some of this predicted image. Number one, where is my image will be located? My image will be located before F. Now my property 1, 2, and 3. What's my size? Well, as you may notice, this is 3 grid, but this is 1 grid, so it's definitely smaller image. Is that inverted? No, it's upright. Or people say erected image. Doesn't really matter which one you use. And when it comes to third one, it's a dotted line, so virtual. That's my example of how you can see a diverging situation. It is really case by case, so you gotta pay attention to the entire situation. Now let's do some lenses. Again, similar situation, somewhere in the middle way-ish. I'll draw PA. Probably I'm gonna move it down like this. And let's say somewhere in the middle, I draw dotted line like this. Let's do a convex lens. What about that? So that's a little fat lens that go like this. Convex lens, ladies and gentlemen, remember, those are the one where you can focus everything. It's a converging. So 1, 2, 3, 4, 5. Why not? We decided 5. 1, 2, 3, 4, 5. Focal point and center of curvature can be located on left side and right side. Depends on perspective. Dotted line versus single line. 1, 2, 3, 4, 5. That's center of curvature C. And 1, 2, 3, 4, 5. Technically located over here. Let's say my image is located, why not, between first focal point and then curvature point. First radiation, like I mentioned, parallel line to the PA. It bends and go to another side because it's refract. That means don't move it towards over there. That's a mirror situation. You gotta aim for focal point on the other side. like that. That is my first radiation, number 1. Radiation number 2, focal point and object, pass through that. Then after that, I go horizontally. Holy moly, we need to actually extend this line a bit longer over here. So in fact, I have to extend everything. Sorry about that, because I'm making the question improv station now, improv style now. So my first radiation and second radiation have intersection point over here, and that is definitely inverted image because the arrow was upright as a start but going down. So first thing first, where is my image? Past the point C. My property 1, 2, and 3. What happened to the size? First of all, equal 1, 2, 3, 4. 1, 2. In fact, it's almost like double the image over here. Has to be precise, so I'm gonna use formula when it comes to tomorrow lesson. But in any case, larger image, solid line that intersects, so it's a real image. And number 3, it is inverted. Order of property doesn't really matter as long as you include these guys. That is an example of convex lens situation. Now let's deal with a I believe I didn't do any of an example that is involved with concave lens. That will be my last example. Decided your PA. There you go. And somewhere in the middle-ish, let's put a concave lens, kind of unrealistically thin lens, but you got the idea. This time, why don't we decide 1, 2, 3, 4, 5? Yeah, why not? 5 as F. 1, 2, 3, 4, 5 as F. 1, 2, 3, 4, 5 as C. 1, 2, 3, 4, 5. That as C. There you go. Imagine this time, you will know diverging type of mirror and lens, they actually have only one type of outcome. They will always have small image, upright and virtual, so it really doesn't matter. But let's say I'm putting an image somewhere extreme, C over here, something like that. It's really located at further location. Now let's deal with our radiation. Now first thing first, radiation number 1, have to pass an object maximum height and all the way towards, and since it's diverging, it's gonna be separating, so you're not gonna go towards a focal point like that, but in fact it's going away. But you cannot just simply put everything like that. You need to extend the line and make sure this dotted line should go through the focal point if it's separating. So that is my radiation number 1. Radiation number 2, you have to go through the focal point, but here's the thing, you're not going towards this focal point. In fact, you're actually going towards the focal point over here, because think about lenses. Lens, you're trying to see something beyond the lens. You're not trying to focus on something before. So that's one simple reason. Go towards, that's a solid line, but after that, it's gonna go off as a straight, but make sure you're extending the line as previous section. Now, here's my refracted image. So, let's put some property. Number 1, it's located before F. Property of the images. 1, 2, 3. The first one basically show smaller image. It is virtual image because it's dotted line, and it is upright. The precise measurement about that will be discussed tomorrow, like I mentioned. So in the end, so Physics 30, if you guys go to page 22 of my Unit C booklet, you will notice that there is a summary of curved mirror and lenses. Depends on whether it's converging type or any type of mirrors, diverging type or lens, those kind of situation. If you really want to memorize, feel free, but there's only a few things that I want you to understand. Number one is, if it's converging and if it's located at F, you should have no image. It's like a blind spot. If you wonder about, you will notice that if the object is located at F, it's impossible to do second radiation. That's why. Because you gotta go past the focal point. Other part, diverging situation. Any location, you will have smaller upright and virtual situation. Generalized situation, real image or inverted, virtual image, upright. Have that in your mind. This may help you. And that's today's lesson. I want you to work on these I'm gonna use for tomorrow's lesson. Why don't you solve every question on this page 24? And related to this, I'm going to give you a worksheet related to lens, mirror, and drawing a ray diagram. So that will be expected for the homework.